Recently, I was looking for inspiration. Something new. Something that comes with a few new concepts to learn, not just a different size or color scheme. The internet has a strange trick. It's an infinite source of ideas, and somehow, at the exact same time, a source of nothing at all. I've just closed the chapter on the TPU flexible drone project, and I was running low on ideas. I've built and flown every size mini quad, different use case, different flight field, and different needs. But it turns out there's only so many remarkable things you can say about 4 motors and 4 propellers before you start repeating yourself. And then, someone from far away felt my struggle and sent something to rescue me from this deeply first world crisis.
Welcome back to Shah's World. This episode we're playing with a miniature Blackhawk RC helicopter, kindly sent over by Razorton, free of charge. With no obligation of any sort, so I'm free to do and say anything about it. Now, product reviews aren't my thing, and in the world of helicopter, I'm a total beginner. But not an ordinary beginner. An FPV beginner. Which means I won't just fly this thing the way it was designed to be flown. I'm going to see how far its actual use case can be pushed. How efficient is a single rotor really? Can this thing fly FPV? What happens if we cut the radio signal or lose the tail rotor entirely? Spoiler, not everything is going to go as planned. So let's have some generally unreasonable fun and maybe learn something on the way there.
For those new to the helicopter world, like me, the Blackhawk UH-60 is in service since the early 1980s and somehow still the aircraft the USA military reaches for when something needs to happen fast. If you have watched any war movie with a helicopter in it, there's a decent chance it was one of these. 70 years of helicopter engineering distilled into one very recognizable shape. And we got an ultra-detailed, scaled-down version of that, which makes it genuinely an excellent display piece, looking cool on the shelf but giving its best in the air. Inside we've got an instruction manual, useful for knowing your possibilities and your limits. Fortunately, there aren't many, because the English translation requires a bit of interpretation. The heli comes with an 800 mAh 1S high voltage battery. No brand name, just blind trust. A vacuum-formed tray, purpose-built to keep every part exactly where it belongs. Respect. An optional but very nice to have pedestal, assembly required. One simple step, maybe 2. A battery charger, also included. Outputs 1000 mAh, so an empty battery should be full in under an hour. Spare main blades, spare tail blade, both without printed graphics for some reason. And a screwdriver, not entirely sure what for, possibly to swap the main gear. Now the main course of the evening, the helicopter itself. Detailed texture, printed graphics, panel lines etched in, which confirms once again its true purpose, being a very nice thing to look at. Affordable 10.24-inch main rotor with a rear swash plate, driven by 3 actual servos controlling actual collective pitch, just like its big brother. Unlike a drone, a helicopter changes blade pitch to generate more or less thrust, while keeping the rotor speed roughly constant. The wheels also roll. Nice touch. Inside the cockpit, another battery. A very nice surprise. And when you're not flying it, mount it on the pedestal and it just sits there, looking incredible. To complete the package, the remote control. Stick, buttons, all the essentials. Feels sturdy, but the buttons are not dampened and definitely rattle. But we were not expecting a premium Radio Master, which would cost more than the entire set. The only thing missing, 6 AAA batteries. Now, a 10-inch plus propeller. That would be for a long-range drone. Bigger prop, better efficiency, that's the rule of thumb. But I like to highlight that propeller efficiency actually depends on airfoil shape, on drag, and on how well the pitch is matched from root to the tip. So without knowing any of that, we don't get to assume anything. We test it on the bench or in the field. For this, we are not just testing the stock 800 mAh battery, we've also got the 380 mAh one on hand, half the capacity, half the flight time? Let's find out. And what about the double the capacity? For that, I had to sacrifice a 3S battery to build a homemade 1S 1500 mAh single cell. Strongly not recommended. Well over 2.5 times the weight. Stock battery. Plenty of people have already confirmed it. 7 to 8 minutes of flight. So let's go straight to the small one, which conveniently fits right into the original battery bay. I handed out to an empty Swiss farm field. No people around, guaranteed privacy. Anyway, let's arm, cut some grass, and we're up. Line of sight, it looks stable, controllable, and some beeping and it landed itself. 13 seconds in. That wasn't me. My guess? The big brushless main rotor sucked that tiny battery straight past its safe landing voltage. But before giving up, let's try again. Rebind, arm, and nothing. It's done. Turns out there's a limit to how far below the stock 800 mAh you can push this thing. Trust me, I'm so disappointed as you are. Let's go with a more interesting option. Will we be close to doubling the flight time? This one doesn't fit inside the cockpit, so a bit of VHB tape mounted underneath. Sturdy. No rattling, should be mechanically fine. Then I discovered the front canopy won't close thanks to the battery wire. No problem, we fly without it. Armed, take off. You can't see this on camera, but the helicopter just kept climbing, straight up until it met a tree. A solid 5-meter drop, quick inspection, somehow intact. No idea what caused that. I genuinely could not stop it from climbing. Let's try one more time. In the air. I had to disarm it mid-flight immediately, before it climbed completely out of control. Last theory before calling it. Maybe it's a weight placement issue. The battery is sitting too far from the rotor axis. Relocated it. Give it one final chance. Nope. One good news at least. We came home with nothing worse than a slightly bent rear wheel. So, the flight time test quietly turned into a crash resistance test instead. The mess with the battery weight and the pre-tuned flight controller has no idea what to do with the extra mass, and the only direction it seems to know is up uncontrollably. With that lesson fresh in mind, I decided to keep the weight as close as possible to stock. So the choice landed on the all-in-one camera and the VTX that came off my very first Mobula 7. To keep the camera holder as light as possible, I added clipping points and the lens holder, then connected them with a silhouette that echoes the original canopy, the one it's about to replace. First pass, minimalist. Almost too minimalist. So I added some material between the thin lines. Then reinforced the side with simple ribs instead of the full canopy. A few more details and we're ready to print. 2 orientations just to see which one actually works. Print 1 problems. Immediately had to file down a good chunk of material. Otherwise, right in the middle of the top, a serious interference. The bottom side felt completely loose. Should be an easy fix. Until I added the battery, and suddenly none of the clips could reach where they needed to be. The canopy needs to be longer. Back to the drawing board, cuts directly on the model. A few nice radii to clean it up. lengthened it so the clips actually engage with the battery in place, added some preload on the bottom clip, widened the antenna hole so it stops fighting me every time, a few tweaks to the side profile and we're good. Also decided the camera should run off the main battery, no secondary power source, no extra weight. And the result? Pretty neat. Aggressive even, if I'm allowed to say myself. For the flight test, I added a bit of extra tape to the clips, a safety margin, just in case, against losing the canopy mid-flight, which, as you're about to see, was an extremely good decision. For the first FPV flight, I came out to this beautiful field of sunflowers. One of the best things about Zurich, you can go from modern city to empty field in about 2 minutes by bike. So I can do my experiments safely and calmly. We are in the air. It works. Pitch and yaw control turned out laggier than expected. The helicopter drifts, and there's not much authority on the right stick. Yaw though, smooth, precise, snappy when it needs to be. But pitch went completely out of control, strong wind, and the heli started sliding backwards. Right stick fully forward, doing nothing. At that point, I disarmed, before it gets blown straight into the river. Bad luck struck again. It came down right in the middle of the narrow asphalt road, and the tail snapped. End of the test one. I promise, this is the last failure of this video. Because despite the disappointment, the fun has to continue. My faithful UV glue joined the two broken halves back together, stronger than before. Years of kids' toys repair experience. So back in the air. This time somewhere a bit more sheltered from the wind. As a beginner helicopter, you don't get any rates or PID tuning possibilities, none. The only option is getting used to whatever you've given. Aside from that, there's a low frequency wobble that I think comes built into how a helicopter's rotor actually works. Here's the simplified version. To move forward, the swash plate tilts and changes each blade's pitch as it spins. If the rotor's spinning clockwise, the blade can get a low pitch on the left side and higher pitch on the right, producing far more forward thrust than backward thrust on each single rotation. Same logic applies to roll, which means the whole rotor disc is by design slightly unbalanced. Not in mass, because each blade weighs the same, but in how it interacts with the air at every point in its rotation. And that's exactly where the dreaded low frequency wobble comes from. All in all, generally nice to fly in FPV. Once you expect the slide, once you stop fighting it, you actually start flying closer to obstacles with more confidence. Could this replace a freestyle quad? Absolutely not. It's just not snappy enough. Could it be a decent long-range cruiser? Actually, maybe. The efficiency of one big rotor is undeniable, and that slow wobble smooths right out in post, especially if you're shooting digital, giving you genuinely nice aerial footage. I'm going to cut this part short in the edit because, ironically, its efficiency is what makes it a little bit boring to watch. Kept this one for last. I figured it would be the most catastrophic, and I didn't want to destroy the helicopter before finishing the other tests. Turns out, we'd already had some generally bad crashes by this point anyway. But hey, not always everything in life goes as planned. So, let's start with a simple one, the failsafe, triggered by losing the radio signal. To test it, I'll switch off the radio mid-hover. Let's see. Does it fly away? Does it drop like a rock? Or does something smarter happen? Trim the radio first. Got it as stable as possible. Hit the power switch and it lands gracefully after 2 seconds, exactly as advertised. Let's do that again. Missed it on camera the first time. Back in hover, radio off, and same result. No flyaway, no dead drop, a calm, controlled descent. Good job, Razorton. Now the last one, the one nobody has an answer for. I'm going to deliberately cause a tail rotor failure, just to see if anything on board even notices. For this, I'm wearing a helmet, because the plan involves knocking the tail blade off mid-air with a pole, and I'd genuinely prefer it not to end up in my eye. To make sure it actually pops off clean, I installed it as loose as possible. Loose enough to still fly, but not much more than that. Helicopters up, moving in closer, lining up the heat. And there it is. Uncontrolled spin, exactly like it would happen on the real aircraft. It hit the ground still armed, flopping around like a fish out of water. No failsafe, no graceful anything, just physics, doing what physics does. And then I just kept doing it. A few more times, no scientific purpose whatsoever. I had a helmet on, I had a pole in my hand, and there was a small flying machine that needed defeating. At that point, I was a knight, a paladin of justice, armored and righteous, locked in a single combat against a $97 Dragon. The helicopter never stood a chance. Science was done. This was just personal. Between the crashes, the tree, the glue, and the one time I genuinely thought I'd lost it in the river, this little Blackhawk went through more than most helicopters see in a lifetime. But that's kind of the whole point of this channel, isn't it? Not being precious about things. Do what normal people wouldn't do, so you don't have to. Thanks for sticking around for this one. If you learned something or just enjoyed watching a helicopter making questionable life choices, that's a win for my book. This has been Shah's word. Go build something, fly something, break something, but responsibly. See you in the next one.